Had some questions on the pre-calculus section 1.4 composition of functions. There was question marks on homework. They were on 29, 31, 33, 35, 37, 45, and 47. So I'm going to go through those problems now in this video. So the function d of p gives a number of items that will be demanded at a price. So p is a price, and d is how many people or what. And c finds the cost, and x is producing the cost of producing x number of items. So x is the number of items. To determine the cost of production when the price is $6, you would do which of the following? So this, you enter a price, you get the number of pieces, items demanded. This, you have the number of items, and this gives you the cost of the items. So which would you do? Cost of production when the price is $6. So price would have to go in, and out would come a demand for so many items. So D would be number of items. So that would have to go into C to find out the cost. So it's going to be P inside going to D, and then that answer going into C. So 6 goes in for the price, gives you D, and D would then be the number of items demanded, and then items goes into C. So there is what you would have to evaluate. 31. The radius in inches of a spherical balloon is related to volume by this. If you take the volume formula for a sphere, the volume is 4/3 pi r cubed. And so if you solve for r, you multiply by 3, divide by 4 times the volume, and then divide by pi, and so that's this, and then you take the cube root. So that's what they've done here, is they've solved for r in this equation. Air is pumped into the balloon so that the volume after t seconds is given by this. So t is in seconds. Give it seconds, it produces volume. So this outcome is volume, where t is seconds, gives you volume, and then volume has to go in place of the v to figure out the r. So find the composition of these. So T has to go in to find the volume, and then that has to go into R, so it's going to be R of, now the variable is going to become T, because we're going to do R of V, which is V of T. So it's going to become R as a function of T. And it's going to be cubed root of 3 times the volume, and the volume is going to be given by 10 plus 20t divided by 4 pi. So you put the seconds in, gives you the volume. 3 times the volume divided by 4 pi, and cube root gives you the radius. Find the radius after 20 seconds. So then you just plug 20 in here. So 20 times 20 is 400 plus 10. So 410 times 3 divided by 4 pi and cubed root. And some of you may not know cubed root, but you do have the power button on your calculator, and cube root is the 1/3 power. So 3 times 410 is 1230 over 4 pi. I presume that you can calculate that, and then to take the cube root of that, you can do it by doing this to the 1/3 power to get your answer. Okay, 33. P is this, M is this, find the domain of M of P of X. So in a problem like this, you have to put stuff in, and domain is what you're putting in. So we have to be able to put it into P. Is there anything that we can't put into P here? Well, first of all, it's a square root, so everything underneath has to be 0 or greater. But 0 would give us 0, and that would make this division by 0, so it can't be 0, and it can't be negative, so far, x has to be greater than 0. The numbers we put in have to be positive, not 0 and not negative. This will produce answers, and then we have to check, will those things coming out of P, putting x in, getting P out, the values you get out, they have to go into M. Is there anything that this can't accept? It can accept any number. Any number can be squared minus 4. So our domain is then, therefore, just limited to what, by the putting it into P. And so the domain is going to be greater than 0. So I would say from not including 0, but up to infinity. Now in 35, we have to put it into G. And to put it into G, we have a division here, and the division can't be by 0, so we can't put 1 in there because 1 minus 1 is 0. So x cannot equal 1. Now, things we get out of here have to go into this one. And so this should never produce an answer that's -3, because -3 plus 3 would be 0. Now, I'm not sure what x would be then, so we have to figure that out. So 2 over x minus 1 should never be -3. So I'm going to find out what makes it equal to -3 so that I can throw that number out. Now, to solve this one, I got a fraction equal to this. I'm going to multiply both sides by x minus 1. The x minus 1's cancel, and I get 2 cannot equal -3 times x minus 1, which should be -3x plus 3. To solve for x, I'll subtract 3, so that's -1 cannot equal -3x. Divide by -3, and x cannot be plus 1/3. So if I put 1/3 into here, I get -3, which I can't use in here. So I can't use 1/3, and I can't use 1 because that causes problem there. So my domain is all reals except 1 and 1/3. Or if you will, from -infinity up to 1/3, not including it, union from 1/3 to 1, not including 1, union from 1 to infinity, not including the 1. This way or that way, either way. All right, let's go to 37. So we have to be able to put it numbers into F to be in the domain. And F is a square root, so we got to worry about it being negative numbers. Now, x minus 2, that's a line. Just looking at the inside, it's got a -2 intercept going with a +1 slope. So this thing is going to be negative for any numbers below, if this goes through minus 2 and it goes up 1, every 1, that's going to be plus 2. Oops, sorry. Way off there. Bring that down. I apologize. Let's start this again. X minus 2. It goes through minus 2 with a slope of 1. So it goes through plus 2 here and minus 2 on the y-axis. That's the inside of this. And I can't take square roots of negatives. Well, it's negative. For all x's over here, this line is negative. It's below the x-axis. So x has to be equal to 2 or greater. 2 or more, and this will not go to 0. 2 makes it 0, and numbers bigger than 2, subtracting 2 are positive. So 2 or greater. So we've already restricted our domain to this. Now the things we get out of this have to go in here. And we're going to subtract 3, so it better not be plus 3. So what we're putting in squared can't equal 3. So what I'm putting in is the square root of x minus 2 into this position, and it gets squared when I put it in there, and that can't equal plus 3. Well, squaring the square root turns out to be x minus 2, and that cannot equal 3. Add 2 to both sides, and that means x cannot equal 5. So we have this stipulation. It has to be greater than or equal to 2, and we have to be careful. We can't put in 5 because 5 minus 2 is 3. The square root of 3 squared is 3. Minus 3 would be 0. Can't use that one either. So the domain will be everything greater than or equal to 2 except for 5, and so I'm going to write it in interval notation. 2 up to, including 2, I can be 2, up to 5, can't include 5, union, I can go from 5 higher to infinity. (37) f of x is a linear function in the form a of bx, where a and b are constants, and we're going to put f inside of f. So we're going to put f inside itself. So f looks like a times x, and in place of the x we're going to put f, which is ax plus b. That's putting that in for the x, and so f would have been ax plus b. So this is f inside of f. And show that this is linear. So this is f of x, and it turns out to be a squared x, and this would be plus ab plus the b here. Well, a times b plus a b is just a number, and a squared is just a number. So we have a number times x plus a number. That's kind of like mx plus b, y-intercept, and slope, and so that's still a line. You need to argue that, so you need to write some words on that. Now find g of x such that a function g of x such that g of x, putting g inside of x, is a line. Well, that's kind of what we did here. We got a line. So the 6 must be the a squared. So the original g must have been the a in it. The original a here must be the square root of 6. So g of x, its slope would have to be square root of 6 times x plus, now we got to find the y-intercept. And the y-intercept is AB plus B, and that's got to equal -8. And A is the square root of 6, so we're going to write, instead of A, we're going to write square root of 6 times B plus B equals -8. And we have to solve for B. So this is a little bit tricky. We have to realize that we can factor a B out of this, and we get B times square root of 6 plus 1. Do you see how this B times this makes this part? And B times 1 makes this. So this is the same as this, equals -8. And to solve for B, we would divide by the number that's times it. So we get B to be -8 divided by square root of 6 plus 1. And there's the line that they were looking for. That's a tricky one. Okay. And finally, 47. A car leaves Seattle headed east. The speed of the car is given in miles per hour after m minutes by this. So S is the speed in miles per hour. C is the speed. And m is the number of minutes. Find a function m, which is a function of S that converts seconds to minutes. So if I give it seconds, like if I give it 120 seconds, I got to find out how many minutes. Well, 120 seconds, I'd have to divide by 60 to get the minutes. So M is S divided by 60. The seconds divided by 60 is minutes. And let's just talk about the units here. So S is in seconds. And if we divide by 60 seconds per minute, to get this out of the denominator, we'd multiply by, just working with the units, I'd multiply by minutes over seconds in the denominator and in the numerator. And this is in the numerator, so the seconds cancel and the minutes and seconds cancel here, and I end up with minutes as my answer. So the function's S divided by 60, and it gives us minutes. Then write out a formula with the new function C of f of s. So we're going to put this was this f that gets seconds and comes up with minutes. We're going to put this in for the minutes in this one. So our new function, C of f of s, is going to be this 70, but in place of minutes, we're going to do s divided by 60. Over 10 plus s divided by 60 squared. So now I can give seconds. This will convert it to minutes, and then it'll do this formula with the minutes, giving me the miles per hour. All right, B. M, which converts hours to minutes. So, which G of H says that we want the minutes if we were given hours. So if we got 1 hour to get the minutes, we multiply by 60. And this would be 60 minutes makes 1 hour times the hours we have, and the units would cancel, and this would give us minutes. So now they want us to write the function, this original function, using it so that it can accept not minutes, but hours, not seconds, but hours. So it's going to be C of G of H, give it H, gives it minutes, gives minutes to the C, and it gives us our speed. So we have to do 70, the minutes is 60H squared over 10 plus minutes, which is what 60H gives us. 60H gives us minutes squared. So there's the answer to B. And this is A. First part for B. First part, second part. All right, C. Z, that converts your speed to feet per second. Now, some of you speed in miles per hour to feet per second. So if I have going some X number of miles per hour, to convert it, I have to get the miles changed to feet and the hours changed to seconds. So I have to multiply by 1, so the numerator and denominator have to be equal. But I want miles to cancel, and I want to come up with feet. So the miles will cancel, but I have to figure out how many feet are in a mile or how many miles are in a foot. And some of you know, some of you are going to have to look it up, but you find out 5,280 feet are 1 mile. So, taking the number we have, miles per hour, times 5,280 converts it to feet per hour, but we want feet per second, so we have to get rid of the hour. So we have to multiply by another 1, which has hours in the numerator, and seconds in the denominator, because we want the hours to cancel and the seconds to show up in the bottom, so we have feet per second. So now we have to determine how many hours make a second or how many seconds make an hour. 60 seconds make a minute, and every minute has 60 minutes make an hour, so every minute 60 seconds. So we're going to have 60 times 60, which is 3,600 seconds, make an hour. And now the hour cancels, and we get feet per second. So the answer is, we want to get V that gives us a speed. Our speed is here. I've made it S. So it's S times 5,280 divided by 3,600. And some of you may reduce that. I don't care if you do or not. So this will give us the, what was it? The feet per second given the miles per hour. And so this is, they call it Z, which is V of S, a function that takes in S and gives the V, the speed in feet per second. And now they say, use that on C of M. Well, C of M, 70M squared over 10 plus M squared gives you a speed in miles per hour. That's what S is, so we're going to put this in place of S, so we have to take it times either this or its reduced form, 5,280 divided by 3,600, and that will convert the speed in miles per hour to feet per second. And this would be what they wanted for that answer, which is V putting C of M inside of V. V takes S, the speed, C gives us an S, and we put it in V. Okay? Lots of units and understanding of the speed and miles per hour and all that kind of stuff involved in this problem.